Welcome to the first video in Exercise 8, Waves. As always, you should have already watched the lab lecture video and read the lab introduction. Today, we're going to look at two different types of waves, standing and progressive waves, their parameters such as wave height, wavelength, and celerity, how those parameters change with variables such as water depth and wave period, and we will be looking at orbital motion as well. In this first video, we will be looking at progressive waves, or waves that move along the surface of the water. To start this experiment, we have a tank on an incline filled with just enough water to reach both sides. The meter stick along the bottom is there so we can measure lengths, and the ruler in the middle so we can measure height. The ruler is taped so that 0 starts at still water level, and we can measure amplitude without having to perform any further calculations. Before we start, we need to measure how deep the water is. For this, the ruler has been moved down so that 0 starts on the bottom of the tank. You might think, how can we measure the water depth if there's an angle? But we're just going to measure the average water depth, which should be right in the middle of the tank. The average water depth is shown here. Please write it down in each box next to water depth, as this will not change between trials. We're now ready to start generating waves and measuring parameters, starting with the 0.5 second waves and moving to longer waves. First, let's measure the wave height of these waves. It can be tough to see what's going on with these waves, especially with the smaller ones, but I will do my best to make it easier to see what's going on. Let's zoom in and slow it down, and then I'll pause it when a crest passes by the ruler. This wave has an amplitude of 0.3 centimeters, or 3 millimeters. You may recall from the lecture that wave height and amplitude are very similar. Wave height is the distance from the bottom to the top of the wave, and amplitude is the distance from still water level, or the middle of the wave, to either the top or the bottom of the wave. Or in other words, amplitude is 1/2 of wave height. So what we're going to do here is measure amplitude and double it to find our wave height. Now that we have amplitude and wave height, let's move on to wavelength. You should recall from lecture that wavelength is the distance from one crest to the next crest, or one trough to the next trough. In terms of us generating waves, we can also think of it as how far a wave gets before the next one is generated. It looks like the waves are being generated at approximately the 67 centimeter mark on the meter stick. So to find the wavelength, let's see how far the wave gets before the next one is generated, and find the difference between where it started and how far it got. I want to show it one more time, as it may not have seemed like an entire wave. But we start with the board being lifted up, generating the wave. The board then gets pushed down and returns to the same position we start in, generating the next wave. So this wave started at the 67 centimeter mark and got to the 52 centimeter mark before the next wave was generated. So by subtracting 52 from 67, we find that this wavelength, or the distance between one crest and the next, is 15 centimeters. The last measurement we must take is wave period, or the time between waves. For this, I will pause the video and put up a timer at the bottom right-hand corner of the screen and play the same clip as before, but at full speed. That went quick, but you can clearly see both wave crests shown here. And the time was 500 milliseconds, or 0.5 seconds. This makes sense as we were generating waves at a frequency of 0.5 seconds. The time between the waves, or the period, should therefore be 0.5 seconds. However, we're not perfect, and this is not always going to match exactly, so it's important that you measure the period in future waves. Now that you have length and time, the next step is to calculate the wave speed, or celerity. Hopefully, you still remember the formula for velocity. Feel free to pause the video here if you need time. Now that we're done with the 0.5 second waves, it's time to move on to the 1 second waves. For these, I'm not going to provide as much information. I will leave it up to you to gather the measurements. Pause the video on each measurement as needed. For wave period, I'm not going to stop the timer. It's up to you to pause the video and find the time. And now we're going to do 2-second waves. We're all done with measurements. Now you must compare and contrast the parameters between the 3 different waves. How did the frequency of the waves affect wave height? What about wavelength? What about period and celerity? That's it for video 1. I'll see you in video 2, where we look at orbital motion.